All right, so the last thing in the 9-4 notes that we need to look at is under number 6, in between 6 and 7, it says the Fibonacci sequence. How many of you have heard of the Fibonacci sequence? Good. So the Fibonacci sequence is a sequence that is actually observed in nature. There are books written about it. You can Google it, get all kinds of good information. But the sequence itself is so famous that I just want you to be exposed to it. I want you all to have seen the Fibonacci sequence. Now, those of you that are familiar with it, what's happening? What's going on, Colin?
It adds the previous two numbers together.
Exactly. So would you say I'm going to have an explicit formula or a recursive formula for this sequence? Definitely recursive, because if I want the next term, I'm going to add these two together. So the next term is 34, and the term after that's 55, and so on. So let's write a recursive formula for this. Now, listen to what Colin said. You add two terms to get the next term. So in other words, if I add some term and the term right after that, do you understand these are consecutive terms? This is like the 5th and the 6th. If I add those two together, then I will get the next term in the line. N, one more than n, so like the 2nd and the 3rd will make the 4th. And then what did we say we needed to make sure we add? What do I need to add? We've got to add on our starting points. You have to know where to start. Kids, could this pattern right here, could it describe this sequence of numbers? Does this pattern right here describe this sequence? Yeah. So what distinguishes them? How do I know I'm talking about that set of numbers instead of this set of numbers? Where I start. Where I start. So when you write a recursive formula, you've got to include the starting point. Now, the ones we looked at.
I talked to about everything we had. I talked to Mr. Freedy, and then Mrs. Song, and then Mr. Wright.
Okay. And what's the status of your past no shaving?
Well, Coach Wright gave me like a special thing to get this weekend.
Okay. Because he knows about that. Well, that's good. I'm glad you went down
Yeah,
with that.
right.
And in the meantime, you look cute.
Thank you.
Now, what the recursive things we looked at last time, we only had the first term. We only gave the first term, but that's because we did something to the first term only. Here, we are doing something to two terms, so we have to define two terms. Okay? All right. The next thing I want you to look at is right there, 9-5, the very beginning. We have to look at all of this stuff. Okay. Let me read you a problem. It's in here, but I don't want to waste time flipping around. Let me read you a problem. Here. I know I have one. It says, okay, a corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats than the row preceding. If the top row has 24 seats, how many seats are in the entire section? Now, do you see a difference with that problem? How many seats are in the entire section? A difference between that problem and the ones that we've been doing. What's the difference? Read that up. Read that up. So 9-5 is the summation section. S stands for sum. All right? And there are 3 summation formulas. You might guess that there is one for arithmetic. This is your arithmetic sum. So if you wanted to add up 100 terms, you would put 100 over 2. What does this stand for? First term, whatever the first term is. What would this stand for? The last term, right? So you want to add up the first and the last, and then multiply it by half of however many there are. This is for arithmetic. If it's geometric, then your formula looks like this. These are derivable, but we just don't have time to do it. So, anyways, that's it. We just don't have time to do it. All right, so a sub 1 first term, R is the common ratio, and N is however many you're adding up. And then this formula, notice there's no N on it, because this formula is the infinite geometric formula. So in other words, if you have a set of numbers like that are geometric, so I'll just pick easy ones, like 1, 1/2, 1/4, 1/8, and it's dot, dot, dot forever and ever, that's summable. And it's summable because it has a limit, right? What's happening to those terms? Where are they going? They're getting smaller and smaller and smaller. So we can find, if we could add all those up from here to Loretto Hall, if we could add them all up, it would be 1 over 1 minus 1/2, first term over 1 minus the ratio. So that's 1 over 1/2, which is 2. So those would add up to 2. 2 is like the limit of all of that. Now you gotta be careful, because what if this were the sequence? Now it's also geometric, but can it be added? If we just kept going and going and going with those, are those addable? No. So you can only use this formula if your ratio has an absolute value less than 1. Because we know that if the ratio is less than 1, the terms are getting smaller, and therefore they're addable. So be careful. So these are the formulas. You don't need to memorize them. I'll give them to you. But these are the formulas that sum. If you want to sum, and you don't want to individually add up, these are the formulas used. Arithmetic, geometric, infinite geometric. Now, this symbol, anybody know what this symbol is? What is that? Well, it means sum. It's summation notation. Anybody know what that letter is? It's a Greek letter. There's no fraternity key. It's a capital sigma. It's a sigma. And to the mathematician, sigma means sum. Okay? So when I look at this problem, it literally says to me, find the sum. Now, find the sum of what? Well, this is the starting value for K. So I'm going to put K, or put 1 in for that K. What do I get? -1. So then I'm going to put 2 in. I put 1 in, I'm just going to go up. I put 2 in, what do I get? 1. And then I put 3 in, and I get 3. And I'm going to keep putting it in until I figure out what's going on. Can you figure out what's going on here? What is happening to these terms? They're going up by 2, which means the sequence is arithmetic, and I'll use this formula right here. Now, I am adding up all of the terms, starting when K is 1, and ending when K is 10. How many is that? 1 to 10. It's not a trick question.
10.
It's 10. count them on your fingers, folks. Finger 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 numbers, right? So I am adding up 10 numbers. My formula says that I take 10 over 2 times the first one, which I already figured out was -1, and I figured it out by putting in this number right here. That gives me my first term. And then the last one, I'll plug in the top number because that's my stopping point. That's where I stop. And so if I put in that, what do I get? 17? So the value of this sigma is 5 times 16, or 80. Sigma always means sum. Always. And so you got to figure out if your sequence is arithmetic or geometric, and then plug into the formula. All right, here we go. Plug in 1. What do you get if you plug in 1? 5. Now I'm going to plug in 2. 11. Now I'm going to plug in 3. What is it? 23. 23. I plug in 4. What is that? 47. Now, there is clearly a pattern going on here, but would you consider this arithmetic or geometric? You think it's geometric? No, you can't be both. You want to be other. You either have a common difference. The difference here is 6. The difference here is 12. The difference here is 24. So it's not arithmetic. Now the ratio, 11 over 5, is this ratio. 23 over 11 is this ratio. 47 over 23 is that ratio. Are those equal to each other? So it is not arithmetic, and it's not geometric. Shoot, how am I going to find the sum? Well, you have some options. Let's suppose, these were the actual terms. I'm going to erase them for a minute. Let's suppose that weren't there. Now let's look at the terms. If I put in a 1, I get 6. If I put in a 2, I get 12. If I put in a 3, I get 24. Now, is that geometric? So this is addable. So I'm going to go ahead and add it. I'm going to add up this part. Now I know I'm missing something, but I'll get it in a second. Let's add up this part. So that's geometric. So my formula says this. So what's the first term? 6 minus 6. What's my ratio? What am I multiplying by? 2 to the 10. And then 1 minus 2. All right, so I'm going to plug that in and get a net number for that. That's the sum of that. So 6 minus 6 times 2 to the 10th equals divided by -1. Did we get 6138? What did I leave off? I left off this -1. So each of these terms, in reality, each of these terms was 1 less than what I added. How many terms did I add? 10. Subtract 10 from this, and that will give you your answer. See how we finagled it, guys? The -1 was messing everything up. So we just took it out, went ahead and found our sum, and then went back and said, okay, in reality, every term was 1 less than what I added. So I have 10 extra in here, so I just subtracted that 10, and I got my answer. All right, next. Now, what's missing in this problem? There's something missing here. What's missing? There's no n. So what's happening if there's no n? It's infinite. Now, not all infinite sequences can be added. Please understand, you cannot add every infinite sequence. What did I tell you the requirement was? Got to be geometric, and the ratio has to be less than 1, have an absolute value less than 1. So what is my ratio here? What's my first term? No, my first term isn't 1/2. My first term would be 3/2, and then my second term is 3/4 and 3/8. What's my ratio? 1/2. So my sum will be my first term over 1 minus the ratio, which is 3/2 over 1/2, which is skipping down to number 2, where you're doing the opposite. You are going to write your own sigma. There is no sigma law that says you have to start with 1. But I think it's usually easier if you do. So I'm going to go ahead and say n equals 1. Now, whatever you put here, kids, whatever you put here, has to generate these numbers. When you plug in 1, you get this. When you plug in 2, you get this. When you plug in 3, you get this, and so on. In other words, you need an explicit formula. You need a formula that you can plug your number in and get the answer. Well, what kind of sequence is that? Arithmetic. And your explicit arithmetic formula is this one. Again, you don't have to memorize it, but you gotta know that's arithmetic. So the nth term, which is what I gotta put right here, that's what goes there, is the explicit term, is going to be the first term plus the common difference times n minus 1. Are you with me still? So simplify it. What is that? 3 plus 4n minus 4. 4n minus 1. Let's check it. If I put in 1, do I get 3? If I put in 2, do I get 7? That looks right, doesn't it? Now, you gotta put a lid on it. This one stops. You gotta put a lid on it. Whatever you put up here, when you plug it in, has to give you 59, right? Okay, so think about that. What can I put in for n that would make this 59? 12? How many 12 works? 15, that's it. You want 4n minus 1 to be 59, guys, so 4n has to be 60, and n has to be 15. There's your sigma. We're going to do the same thing with the letter B. You're going to write your own sigma. Can you tell what's going on in this problem? What are we doing, On?
It's getting multiplied by a common ratio of 1/3.
And what is that ratio?
1/3.
Negative 1/3?
Yeah.
Negative 1/3. So my ratio is negative 1/3. So my first term times my ratio to the n. that is my explicit term. Here's your formula. That's my explicit term right there. So I'm going to put that right here. And I'm going to check something. If I put in 1, do I get the term I'm supposed to? Oh, shoot. That's supposed to be n minus 1. Now if I put in 1, do I get the term I'm supposed to? What happens if I put in 1? That's a 0. Anything to the 0 is 1, and 4 times 1 is 4. How far am I going? Well, this is an easy one. How far am I going? 11. Yep. How do we know it's 11? Because the last term is to the 10th power. So it has to be. Now, what did you say? Did you say something else? Oh, okay. All right, are you okay with that? Figure out if it's arithmetic or geometric. Use your explicit formula for whichever kind it is. That's what goes here. And then make sure you got your ending number right to generate your last term. All right, 3 is the problem I was talking about earlier. Let's see if we can answer this question now. It's a word problem. We want to know how many seats are in the section. First row has 8. Second row has 10. Third row has 12, and so on. And the top row has 24. Dearby, are you okay, honey?
Yes.
Okay. All right. I gotta add these. It's clearly arithmetic, right? And the good news is, I know that the first term is 8, the last term is 24. And that's what my formula requires. This is the arithmetic sum formula. And I gotta know first and last, and I have those. What do I not have that I also need?
Which term 24 is?
Exactly. How many am I adding up here? Well, could you figure it out? Yes. You could probably figure it out several different ways. But if you're going to do it like mathematically, and sequences are patterns and logical, so I don't care how you do it, but if you want an actual math way to do it, you could say 24 has to equal 8 plus 2 times n minus 1. Remember your arithmetic formula? It says the last term equals the first term plus the common difference times n minus 1. Is that solvable for n now? Could I figure out what n is? Yes. So if you want a math way to do it, go back to your formula, your explicit formula, and you do it. You guys are smart. You want to do it lots of other ways. Looks like there are 9 of them. So that would be the answer to the question, whatever that is when you figure it out. All right, part 4, determine whether the series converges. If it converges, get the sums. So let's, first of all, let's go through and figure out which ones we think converge. Converge means it's summable. It has a limit. The terms have a limit. So look at question A. Summable? Yes, because the common ratio is 0.75. Less than 1, add it up. How about B? Yep, it's summable because the ratio is -4/5, And that is absolute value-wise less than, well, period, is less than 1, right? How about C? No. Pi is 3 point something, so that ratio is actually like 1.5. Can't sum it. So cross C out, can't find the sum. D, we've already done. D is summable because the ratio is 1.5, and I already added that one up. Let's add up A and B. Make sure you can use your formula. They are infinite. Does everybody see that? They even put an infinity symbol on there. So you see it's infinite. What's the first term? Now, the first term is found by plugging in this number right here. Whatever that is, it does not have to be 1. It's easiest when it is, but it doesn't have to be. This is the beginning node. That's the starting K. So when I plug in 1, I am going to get this, aren't I? So the first term is 3, and the ratio is 0.75. So that's 3 over 1/4. Did you get 12? The sum is 12. The answer is 12. When you see a sigma, you're adding them up. Your answer is going to be a number. All right, last one. Here we go on this page. B. I'm going to add it up. I'm going to use that same formula, so I need my first term. What's my first term this time? Watch it. 1. Why is it 1? Because I'm plugging in 0. And when I plug in 0, I get 1. So my first term is 1. What's my ratio? Be careful. My ratio is negative 4/5. So this becomes plus 4/5. So I have 1 over 9/5 or 5/9. So the sum of that series is 5/9. All right, we're going to do one more kind of newish, type-ish problem, and then we're going to do some more sums just to practice. Would you turn to number 8? I'm just going to flat out tell you this problem's on the exam. Won't one like it? You'll see it on the review sheet.
The final exam or the chapter 9?
On the exam. It's probably also on the chapter 9 test, but you're not taking that unless you just want to. Do you want to run? Okay. I do need you to fill out the class survey though. Okay, it's in Schoology. All right, so this question says, a ball is dropped from a height of 10 feet. I always like to draw pictures, so I'm going to draw 10 feet. Each time it bounces, it rebounds 0.95 of the distance it fell. So 0.95 times the distance it fell. 95% of the distance it fell. So this first time it bounces up, it's going to go up 9.5. Would you agree with that? And then, of course, it's going to come back down 9.5. And then what's it going to do? It's going to go back up, and I don't know what the number is, but won't it be 0.95 times this? So 0.95 times 9.5. And then it falls that much, and so on and so on. Okay? Understand what's happening? Now, the question is, how far will it travel before coming to rest? So give me some thoughts on that. How far will it travel before coming to rest?
The sum of how much it goes up and down.
Okay, so Seth says, really got to consider two things here. I have to add up my downs and add up my ups because it's doing both of those. So let's look at the downs. So we're only gonna look at the downs first. So we've got this, and this, and this. What would those numbers be if I wrote them out? 10, 9.5, 0.95 times 9.5, whatever that is, and so on. Arithmetic or geometric set of numbers. Clearly geometric, and the ratio is 0.95. So my sum of the down distances will be 10, first term 10, over 1 minus 0.95. Which is 10 over 0.05, if I just go ahead and subtract that. Which is what? What is it? 200? And that would be feet. Is everybody okay so far? Now I say so far because the question was, what is the total distance that the ball traveled? The total distance, right? So now wait a second. This is not the total, this is only the downs. So how am I gonna get the ups? Mallory?
Well, what if the ups be the same as the downs?
So the downs will be the same as the ups. So the ups will be the same as the downs, somebody said, except for this first term. So if the downs add up to 200, what do the ups add up to? 190. And then the total distance the ball travels before coming to rest would be 390. How else could you do this? That's great. I love that. That's how I would do it. But you could do it a different way. How could you do your ups? Could you do another calculation? Yep. But your starting number wouldn't be 10. It would be 9.5. And that would give you exactly the same number. Now, what if the ball were thrown? How would that change things if the ball were thrown? Colin?
The ups would also start at 10.
Which means the ups and downs would match exactly. So that would be 400. Does that make sense to everybody? All right, what I want to do now then is back up a page. I am really sad we're not getting to do some of this other fun stuff. I'm so sad. I want to look at number 7. And I want you to see how many, take a couple minutes, I want you to see how many of these sums you can calculate. So, you're adding up all these terms. So see how many of these you can figure out without my help. You can get help from your partner if you wish. Let's see how many of these you can add up. Some of them are easy. We'll start with the first 4. This is the first 4 down. Come on, pencil and paper. Let's see what you can figure out. Some of them are harder than others. So we're summing, so we know we're either going to be using that formula, that one, or that one. Lane, Aiden. Is there an AP test this afternoon? Physics 2, are they probably in there? Are they? Yes. Anne is probably playing soccer somewhere. You guys, there is no talking. There's no reason for there to be any talking except with your partner about math. You are right. You are marked absent. Has anybody gotten any of these yet? First one you got? First one I think is kind of a hard one. What's happening in the first one? Your difference is -7, right? You're adding -7, which makes it arithmetic. I got my first term and my last term, but what important piece of information is missing? How many there are? So we said you can think about it, logic it out, or you can use your formula, which says the last term is the first term plus the common difference times n minus 1. Arithmetic. Last term equals first term plus common difference times n minus 1. And you can just solve that out. I got 13, is that what you got? So there's 13 of them in there. And then we can use our formula. And the sum is 845. Does anybody have a question about that first one? Okay. Did I get another one? Anybody else get another one? Is this one kind of the same issue, except it's geometric? So that formula says first term minus first term times ratio to the nth over 1 minus the ratio. The problem is I don't know how many terms there are here. So I can think about it, you'll process it however you do, or I can go back and use my geometric formula, which says this last term equals first term times ratio to the n minus first. Oh, that's not quite as easy to solve as this one. What would I do first here to solve that? Yeah, let's divide by 3. So I get 4096. Now, I want you to think about this. What kind of a number does n have to be? N represents how many terms there are in this list, right? So how many of those are there? What kind of number? What kind of number am I going to get? Am I going to get 16.78? No, I'm going to get a whole number. So you can go with logarithms if you want, because that's an exponential. You can take the log of both sides. Or, since we know this has to be 2 to a whole number power, I can trial and error. So what's 2 to the 10th? 1024, not big enough. So what's 2 to the 12th? 4096. So this number is 2 to the 12th. You can't get away with that in normal math land. But you know this has to be a power of 2 because n has to be a whole number. So it looks like my exponent is 13 again. N minus 1 is 12. So 3 minus 3 times 2 to the 13th. I got 24,573. did you notice this here at the end? That means it's infinite. So that means I gotta be using this formula. What's my ratio? 1/2? I get 12 for that one, that seemed easy. This looks like the same thing. Whoops. Whoops, what's wrong with that one? We're multiplying by 3. Our ratio is 3. You can't sum that one. The terms just get bigger and bigger and bigger, so there's no way to add them up, Hank?
Couldn't the sum just be like 1 here?
Well, I guess technically it is, because we're going to infinity. But, so then after you added this term, and you said, okay, this is on the infinity, what about when you have the next term? It just runs into all kinds of weird complications. So we just say no sum, not summable, divergent, which is the opposite of convergent. Okay? All right, so that right there, guys, is all the nuts and bolts. You